AIM 11.6, margin of error, and your homework is delta math. Now, you've probably seen this or heard this expression before. When you're watching the news and a poll is released, and at the bottom, there's a number that says plus or minus such and such. That would be the margin of error. So we're going to learn about how we get that number and what that number represents. Okay, so in inferential statistics, we attempt to infer characteristics about the population from sample statistics. But these inferences always have a degree of uncertainty to them. Many times, this uncertainty is quantified by a margin of error, which is a measure of how accurate we believe our sample statistic to be relative to the population. The larger the sample size, the smaller the margin of error. There is less variability when more people are sampled. Outliers will have less of an impact on the overall result. So, for example, think about a national poll. In order to figure out how people feel about something, you're not going to poll everyone at one time, but you may take smaller samples. And of course, your sample should be as unbiased as possible and should be random. And if your sample size is large enough, it can be indicative of how the population as a whole will be swayed. Now, of course, it's not a complete science, so there's, quote, a margin of error. So right now we're going to determine how we find that margin of error and what that represents. So which range here represents approximately 95% of the population? Well, I see that from -2 to 2 represents 95% of the data. So that would be considered 2 standard deviations. So margins of errors and confidence interval. The margin of error allows us to give a range of values that are reasonable for a population parameter based on a sample statistic. We will consider what is known as 95% margin of error. Although there are many others based on confidence intervals. The 95% margin of error. The uncertainty level that would guarantee a 95% chance that your population parameter falls within a certain range of values. Since approximately 95% of all normal distribution falls within 2 standard deviations of the mean, we use 2 standard deviations to develop the margin of error. So going back to the slide here, you know that a 95% confidence interval or margin of error is saying that we don't know what the results might be. We hope that it's close to the mean here, and we believe that it is based on our data. However, we could be off. So perhaps the result may lie here, it may lie somewhere over here. But if you give it a 95% confidence interval, that means that you're sure that your real number will lie between -2 deviations and 2 deviations from the mean. So you're giving yourself a wide berth. Okay, so as we went over before, when you have your large sample size, you can derive your standard deviation by taking the square root of your population proportion times 1 minus that population proportion divided by the number in the sample size. Okay, but how do we determine what the margin of error is? The standard deviation involves the parameter that p is being estimated. Because p is often not known, statisticians replace it with the estimate, p hat, in the standard deviation formula. This estimated standard deviation is called the standard error of the sample proportion. So here, if we want to get the margin of error, since we know that our standard deviation, one standard deviation, I'm going to go back to the last slide, is this. If we want 2 standard deviations, we're going to multiply that by 2. Now, because we don't know necessarily how the entire population would feel about a matter, we are going to use the sample proportion, or p-hat, instead of the population proportion. And when you multiply all of this by 2, you're saying that the standard deviation will be within a 95% confidence. Okay, so the central limit theorem. When a sample size is fairly large, say 30 or more, the distribution of all means in a given size n will be normally distributed with a mean, mu x bar, is equal to mu, or the mean of the sample will be the mean of the population. And the standard deviation, sigma x bar, will be equal to sigma divided by the square root of n, which is the variation. The variation of means is smaller than that of the population. Okay, so I've thrown a lot of stuff at you guys. So let's look at some examples. So a study was commissioned to find the mean weight of the residents in a certain town. The study found a confidence interval for the mean weight to be between 155 pounds and 171 pounds. What is the margin of error on the survey? So first we have to determine the mean. So if you're at 155 on one end and 171 on the other, your mean will lie in the center at 163. So now how do we determine the margin of error? Well, we look at the difference here, and the difference is 8. 155 is 8 away from 163, and 163 is 8 away from 171. And so the margin of error here is 8, plus or minus 8. So the margin of error for proportions. A survey is given with a random sample of 950 voters in the United States. A sample. No. A sample was given to a random. A survey was given to a random sample of 950 voters in the United States to ask about their preference for a presidential candidate. Of those surveyed, 52% of the people said they preferred candidate A. At the 95% confidence interval, what is the margin of error in the survey expressed as a percentage to the nearest tenth? And here, we're not going to write plus or minus. Plus or minus is always inferred. So our sample proportion here is 0.52 because it's 52% of the people preferred candidate A. And we're given that our sample size is 950. So with this information, we can determine that our margin of error, we can use this formula for our margin of error. And when we plug those numbers in, we get it's approximately 0.03248183. And if we were to convert that into a percentage by moving your decimal space 2 spaces over to the right, you would get that the margin of error is approximately 3.2%. So when the election happens, people would say, we believe that this is how the people will vote. 52% of the people said they would vote for candidate A, but the margin of error here is plus or minus 3.2%. So candidate A may actually get 55.2% or not. Candidate A could also get, was that 48.8%? Think so? Yep. So those would be the tail ends, but your answer could lie anywhere in between 48.8% and 55.2%. So the margin of errors of means. A study is commissioned to find the mean weight of the residents in a certain town. The study examined a random sample of 63 residents and found that the mean weight was 169 pounds with a standard deviation of 39 pounds. At the 95% confidence interval, find the margin of error for the mean, rounding to the nearest tenth. And once again, we don't need to write plus or minus. So here we have that the mean is 169, and our standard deviation is 39. So here we use this formula for margin of error. And when we plug it in, we get that the margin of error is 9.8. So we are 95% confident that the true mean weight of the population is within 9.8 pounds of the sample mean of 169. So example 4, confidence interval for proportions. A survey was given to a random sample of 145 residents of a town to determine whether they support a new plan to raise taxes in order to increase educational spending. Of those surveyed, 116 respondents said that they were in favor of the plan. So determine a 95% confidence interval in which the proportion of people who favor the tax plan, of the proportion of people, for the proportion of people who favor the tax plan, rounding values to the nearest thousandth. So here we get that our sample proportion is 0.08. So we take our 116 and we divide it by 145 because that's the outcome for our proportion, or that's the outcome for those that were in favor of the overall. And our sample size was 145. So here we calculate the margin of error to be approximately 0.066. And so if our sample proportion is 0.8, it's going to be plus or minus 0.066. So when you add 0.066 and you deduct 0.066 from 0.8, we get this range of numbers from 0.734 to 0.866. So essentially 73.4% to 86.6% of those people would be in favor of the plan. So example 5, confidence intervals for means. A study was commissioned to find the mean value of the residents in a certain town. The study examined a random sample of 138 residents and found that the mean weight was 177 pounds with a standard deviation of 34 pounds. Determine a 95% confidence interval for the mean, rounding all values to the nearest tenth. So here we get that our mean is 177 and our standard deviation is 34. So once again, we determine the we determine the margin of error, the 95% confidence, and we get that's approximately 5.8. So when we do that, we get 177 plus or minus 5.8. And so the range, the confidence interval will range, the people that would be covered here, or the weights that would be covered, that would represent the mean weight, would be between 171.2 and 82.8. So we are 95% confident that the true mean weight of the population is between 171.2 and 82.8 pounds.